All right, let's talk about what might be the single most audacious announcement Elon Musk has ever made. And honestly, coming from him, that's really saying something. We're diving into Terafab today, a project so enormous it could completely reshape Tesla and maybe even the future of tech, both here on Earth and way up in space.
Just let that sink in for a second. This is the guy who built reusable rockets that land themselves, who's deploying a global internet service from space, and who turned an electric car startup into the most valuable automaker in the world. So to call this his most ambitious project, that bar is set ridiculously high. So what in the world is it?
Okay, at its heart, Terafab is a proposed $25 billion chip factory, but its goal is just staggering, to produce 1 terawatt of AI compute every single year. To try and wrap your head around that number, that's 70% of the entire global output of TSMC, the undisputed king of chip manufacturing, all from one building. The scale is just mind-boggling.
Now, when you hear a number like that, it's totally natural to be skeptical. I get it. But to really grasp what Terafab could become, you kind of have to look backward. You have to see the pattern of these supposedly impossible projects that are now just part of our reality. You know, the single most important tool we have for looking at this whole thing is simple pattern recognition. Because time and time again, we've seen this play out. A massive, Musk-led project gets announced, experts everywhere line up to call it crazy, and then, eventually, it delivers on its core promise.
I mean, just look at SpaceX. Back in 2002, the entire aerospace industry was literally laughing at them. After 3 straight launch failures, the company was basically out of money and on the verge of disappearing. But fast forward to today, they are the absolute, undisputed leader, with 134 launches in a single year and a near-perfect success rate. It went from a joke to the benchmark everyone else is chasing. And it's the same story with Tesla, right? The Gigafactory in Nevada was dismissed as some kind of vanity project. The ramp-up for the Model 3 was famously called production hell, a time that almost destroyed the company. And yet, look at them now, the most valuable car company on the planet. The pattern is just undeniable. It's extreme ambition, followed by brutal, near-death challenges, and then ultimately success that redefines an entire industry.
So, this is the really crucial point. Timelines? They might slip. For sure. Budgets? Yeah, they might get bigger. But history has shown us, very clearly, that betting against the fundamental direction these projects are heading, well, that's been a losing bet every single time. And Terafab, it's just the next massive directional bet.
So what is it that actually makes Terafab so different from any other chip factory in the world? Well, it really all comes down to one core idea, and the insane speed advantage that it creates.
And that one big idea is vertical integration. See, Terafab is designed to have every single step of making a chip, every single one, happen under one roof. We're talking from the very first design sketch to the fabrication, the packaging, and this is the really critical part, the final testing.
If you look at how chips are normally made, it's this incredibly slow, fragmented process. You have a design, you send it out, you wait for a vendor, you wait for your spot in line at a foundry like TSMC, then you send it somewhere else for packaging. A single loop can take 6 to 9 months. Terafab wants to do that entire cycle, in-house, in a matter of days. And what this creates is this unbelievably powerful recursive improvement loop. When you shrink that design-build-test cycle from months down to just days, you could potentially do 10 versions of a chip in the time it takes a competitor to do 1. Over a few years, that's not just a small advantage. That's like compound interest for innovation. It could create a tech gap so big that no one can ever close it.
So what are they actually planning to make here? Well, it's mainly 2 kinds of chips. First, there's the AI-5 chip. That's for use down here on Earth, powering everything from full self-driving in the cars to the Optimus robot. And then there's the D3 chip, which is a special processor hardened to survive the harsh environment of space, built specifically for a fleet of orbital data centers.
Now this is where the story gets so much bigger than just Tesla. Because Terafab isn't really just a Tesla project. It's the keystone that locks Tesla, SpaceX, and xAI together into this incredible, symbiotic ecosystem that no other competitor on Earth can even hope to replicate.
Just look at how the pieces fit together. You've got Tesla, bringing chip design, insane manufacturing scale, and energy infrastructure. Then you have SpaceX, which provides the world's cheapest and most reliable ticket to orbit. And then you have xAI, bringing the cutting-edge AI models and the massive training compute. I mean, who else has all 3 of those pieces? The answer is absolutely nobody.
And what this creates is this powerful, self-reinforcing flywheel. It starts with Terafab building the chips. Then, SpaceX launches them into space for cheap. Up there, these data centers run massive AI workloads powered by free, non-stop solar energy. And finally, Tesla and xAI use all that cheap compute to make their products way better, which of course drives the need for more chips. It's a perfect closed loop, where every part makes every other part better, faster, and cheaper.
But here's the part that is just truly wild. The part that's almost hard to believe. It's where these chips are planned to go. An estimated 80% of Terafab's enormous output is slated for space. We are not just talking about a factory to supply cars and robots. We are talking about building a constellation of 1 million solar-powered AI satellites orbiting the Earth. Okay, as incredible and futuristic as this all sounds, we've got to bring it back down to Earth for a minute. This is a monumentally ambitious plan, and with that level of ambition comes an absolutely enormous amount of risk. So let's get real about the hurdles and what the different outcomes could look like.
And look, these risks are no joke. For starters, Tesla has exactly zero experience in semiconductor fabrication, which is one of the most difficult engineering disciplines on the planet. The cost could easily swell way past that $25 billion estimate. We don't have a clear timeline, the main AI5 chip isn't even done yet, and maybe most telling, the financial market is acting like this has a 0% chance of succeeding.
So really this leaves us with 3 possible futures. Scenario 1, which is basically what the market is betting on now, is that it just fails. Tesla stays a customer of TSMC. Scenario 2 is partial success. They figure out how to make their own chips, which unlocks incredible scale for their cars and robots. And then there's Scenario 3, full success. The orbital compute vision actually happens, creating a brand new trillion-dollar market from scratch. The gap between what's expected and what's possible is just vast.
It really just boils down to this. This is a binary, all or nothing bet. For $25 billion, maybe more, Terafab will either be the single most important project in Tesla's history, the thing that secures its dominance for the next generation, or it will be its most expensive mistake ever.
So I'll leave you with this question to chew on. When you look at the plan to integrate manufacturing on Earth with infrastructure in orbit, all powered by artificial intelligence at this kind of scale, you just have to wonder, are they even building a company anymore? Or are they laying the actual technical groundwork for a galactic civilization? The ambition, at the very least, is out of this world.